Okay, let's go ahead and take a look at some of the notation around sampling distribution. So look at this table of values. And remember, we have parameters, which are the values for the population that we want to know and want to determine. But we use statistics to try to determine those as estimators. X bars, means, right? S, sigma, sample standard deviation, population standard deviation, so forth. We don't use variance, remember, that much yet. That's in future classes. Proportion, sample proportion, population proportion. And so with this new idea of sampling distributions, right, we have some new symbols over here. You have the mean of all possible sample means. Remember, if we do multiple samples over and over, if we take samples over and over again and calculate those means, we could do the mean of all the sample means. And that's what that symbol is with that little X bar. And then we would also have a standard deviation for all the sample means. That's called the standard error. Very important to remember, make a note of in the notation, the sigma with the X bar. And then we also have the p hats in the next section, but and the sample size. So as we said, right, we would have a good approximation for the sampling distribution of a sample mean, right, if we take samples over and over again, as it states there. And so what we have is, now remember, we're looking at the sampling distribution. Like we're looking at multiple means from different samples, not from individuals. We're looking at the sample mean in a bunch of distributions. And so we know the shape of that sampling distribution would be normal, right? If the population is normal or the sample size is at least 30, the center of that sampling distribution is going to be the actual population mean. So we're assuming that the mean of the sample of means will be the actual mean because it's an unbiased estimator, the sample mean. And then the standard error, right, is your standard deviation divided by the square root of n. And that's how we would calculate the standard error. Remember, because we're looking at a sampling distribution of sample means, not just from individuals. And so you want to make a note of that too, and how we use that. Now, in this example here, here's an example, just looking at describing, right? Remember the sampling distribution of a sample mean. We have some basic values. There's no data here. It's just we're doing a simple example to kind of demonstrate. If you have a population mean of 30 and a standard deviation of 3.5, right, and it's slightly skewed, what do we know about the distribution, right? What do we know about the sampling distribution of if we did these sample means over and over again, right? I'm sorry, samples from a population that we know has a mean of 30 and standard deviation of 3.5. If we know that, then we know the shape, right, of the sampling distribution is going to be normal because the sample size is bigger than 30. Even though the population skewed right, the sampling distribution will be normal. The center will be 30 because we know the mean of the sampling distribution equals the mean of the population. And the standard error, the standard deviation of all those samples would be 0.553. It's the sample. It's the population standard deviation divided by the square root of n, the sample size. So you have an example. This is in a video an example, right? So take a look at that one. It's in the homework, right? Here are the notes that you have here. But when we look at this, right, and think about how is this going to be different than our Module 7 questions. So we're going to have very similar probability questions, right? What's the probability? But notice I'm looking for the probability that the mean is greater than 2.2 in this case, as you look at this scenario here, right? You're planning a full day nature trip for 50 men, and will bring 110 liters of water. What is the probability that you will run out? Meaning that, again, that you don't have enough water for those 50 when we know the average man drinks 2 liters, right, when active, with the standard deviation of 0.7. We have this given information. And then now we're looking and analyze what will happen, the probability, not of an individual, but of a sample. In this case, a sample of 50 men. And so you would use the ARTISTAT, and that's, you see this calculation here where we get that answer using the ARTISTAT. But look at the video for that one, okay? Now, let's finish this video looking at a sample problem, again, in addition to this one here that you'll look at the video online, is here's a scenario where you have the average, the mean weights of males and females, standard deviations. The shapes are normal for the population, okay? And then we're looking at when designing life rafts, it's important to consider the weight capacity, obviously. Let's say Santa Ana College was buying life rafts, have 16 people, they can hold 16 people, and the capacity is 2,400, right? And the life raft is going to be loaded with 2,400 pounds, 16 males. So let's think about this. What kind of information do we need to answer a question like this? Find the mean weight of the passengers. Well, again, thinking about if you have 2,400 and 16 males, that would be an average weight of 150, right? If you have that many. And we want to now calculate the probability that a single male weighs greater than 150 pounds. Well, we have some information. We'll use the ARDA-STAT to answer that. Again, we're looking for the probability that a single male weighs more than 150 pounds. So we know the mean is 182, standard deviation 48.3, and then we can just calculate greater than the upper tail, and you put 150 in there. And we got it. So now we have the answer. There is a 76% chance, right, that a single individual male will weigh more than 150 considering this distribution. So that answer to that question now, right, using that normal calculator ARDA-STAT is 76.96%. That's the probability, or 0.7696. Now, let's look at this updated question. Find the probability that the sample of 16 males has a mean weight greater than 150. We care about that because if that's true, then we know we're going to be above capacity. They won't fit on the boat if their mean weight is greater than 150. To calculate that, notice it's an X bar, that the mean is greater than 150. We're looking at a sample distribution. I need to calculate the standard error. We know the mean is equal to the population mean, the sample distribution. The mean is equal to the population mean, so we know that's going to be 182.3. And then in this case, instead of using the standard deviation of 43.8, we're going to use 10.95. We use the standard error calculation, and then we use the ARDA-STAT to do that calculation. So with the ARDA-STAT, we have that mean, but now we have the updated, right, the adjusted standard deviation, or the standard error of 10.95, and I want to know again, now that the mean, I want that to be greater than 150, and now we have an updated answer of 0.9984. Notice this is the sampling distribution we're looking at now because it's the adjusted standard deviation. So pretty much we're certain 99.84% chance that these 16 males will have a higher capacity than the 2,400 pounds or have a mean weight greater than 150.